In this problem, we're going to investigate use of the product and quotient rules in taking derivatives. Under this rule, we begin with a function that is a compound of two other functions, a product of two other functions, such as f and g. We take the derivative of f times g plus f times the derivative of g. In a case like this, we would start with f being x squared and g being e to the x. For example, we would do the derivative of x squared being 2x times e to the x plus x squared times the derivative of e to the x, which is e to the x. This is the derivative of x squared e to the x. If we want to try a different example, we'll let the function h be 1 plus x to the power 3 and k equal e to the power of x. The derivative of h times k is the derivative of 1 plus x cubed times e to the x. To evaluate this, we first take the derivative of 1 plus x to the power 3, which is, the derivative of 1 is 0. The derivative of x to the power 3 is 3x squared times our second function, e to the x, plus our first function, 1 plus x cubed, times the derivative of e to the x, which is e to the x. Now, likewise, we can also turn around and use the quotient rule. This rule is, we can write it out quite simply right here. However, we can also remember mnemonically as, if we remember h is our low function and f is our high function, low d high minus high d low over the square of what's below. If not great poetry, certainly a very useful mnemonic. In this case, we will take our original two functions, f and g, and find the derivative of x squared over e to the x. The derivative will be our low function times the derivative of our top function, which is 2x, minus our top function, which is x squared, times the derivative of our bottom function, which is e to the x, over the square of the bottom function. This is the derivative of x squared over e to the x. Now we can certainly simplify this, but I'll leave that to the interested reader, student. For our final example, we will take h and k functions, which we defined previously just a moment ago, and apply the quotient rule. Okay, so we take our low function, low d high, the derivative of the top one is 3x squared minus high. Okay, notice I left the 0 out because it really wasn't necessary. We took the derivative, same right here. The 0 adds nothing to it, so I left it out. Okay, low d high minus our high function, 1 plus x cubed d low, our bottom function, derivative of our bottom function, over the square of what's below. This is how we apply the quotient rule, which is really a special case of the product rule, but nevertheless it comes in very handy very often, and it would be very useful to remember it. But in any case, it is essential to know the product rule backwards and forwards.